Hey, grade 11s. I want to look at another method for finding x-intercepts from vertex form. Traditionally, for the vertex form, you would have to expand the brackets and use factoring or a quadratic formula to solve. Today, I'm going to look at another way we can solve just using algebra. Starting with this equation here. Since we're trying to find the x-intercepts of this, let's make a statement first. So let y equal 0, because those are where we find our x-intercepts on the x-axis. 0 is equal to negative 1/3 x minus 7 squared plus 11. From here, we want to slowly isolate for the x. Imagine we are solving an equation. Well, we are. We need to, step by step, move everything to the other side to isolate for x. We can do this because x only occurs in one location. In standard form, we don't have that luxury because we have multiple places where x exists. Okay, let's move the 11 over. We get negative 11 is equal to negative 1/3 x minus 7 squared. From here, we need to get rid of this negative 1/3. Opposite operation says to multiply by a 3 and also a negative to make the right side positive. So we'll do the same thing to this side. We'll do a negative 3 multiplied the negative 11. We now get 33 on the left side. On the right side, the 3's cancel and the two negatives become positive. We're left with x minus 7 squared. As a quick side note, in this formula here, we had it in vertex form. We could draw a sketch. The vertex is located at 7, 11, something like this. And we would predict even from the get-go, because of that negative a value, this parabola would open downwards. And we would see that we get two x-intercepts. The reason why I'm pointing this out to you is that we should predict from solving this equation we get two x-intercepts. The only way to do that is to remember, whenever we take a square root of an equation with variables involved, we must consider both the positive and the negative version of the number we square root. So over here, when we take the square root of the 33, we must remember to also include a plus or minus sign in front, signifying that we will get two possible solutions, because negative 5 times negative 5 is positive 20, but so is 5 times 5. Okay, to keep things exact, I'm not going to square that 33. We are going to end up with plus or minus the square root of 33 is equal to x minus 7, because these two are opposite operations, squaring and square rooting. Move the 7 over to the other side, we get two solutions. 7 plus or minus root 33. Well, the first solution being x1 is equal to 7 plus the root of 33, and x2 is equal to 7 minus the root of 33. And here's your alternate method for finding x-intercepts. This works quite the same way as quadratic formula works, and the benefit to this versus using a factoring method is that there is no guess and check involved.